Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the binary search tree insertion. And for this particular challenge, we are given a pointer to the root of a binary search tree and values to be inserted into the tree. Insert the values into their appropriate position in the binary search tree and return the root of the updated binary tree. We just have to complete the function. And in the format, we are given a function called the public static node. It is the expected data type, which is node, and the name of the function itself, which is insert. And we have two parameters. The first one, which is the root, and in the form of node from the custom class node right here. And then second parameter, which is the data, which in the form of integer, and we need to insert the data as a node on the appropriate position. And for this constraint right here, which is number of nodes in the tree, and it is always equals or below 500 nodes, the total of nodes of the total constraint of the max test cases. And for the input output format, we have to return the root of a binary search tree after inserting the value into the tree. So in short, that we need to create a new node and then insert it to the appropriate position from the existing binary tree nodes right here from the tree composition. And we have the sample input of the parent node, which is 4, and we have the root 2 as the left property and node 7 as the right property from the node 4, and we have node 1 and 3 from the branch of the node number 2, and the value to be inserted is 6. Then we need to insert 6 onto the appropriate value, and we have 4 to 7. And if you notice right here, we have 1 which is placed before the 2, which is placed on the left property, and the arrangement is the left first as the least value, the data value, and then the middle part, and then check if the right side is higher than the root or the parent node, then we will insert the higher side to the left side, to the right side, I'm sorry. And for this part of the challenge, we have to recursively looking through the appropriate position, and we have the value of 7 right here, which is, and 6, that the value to be inserted is 6, then 6 is less than 7, and then it will be placed on the left side. And to look over this recursively, we are checking the 4. We are checking the 4 as the node, and then recursively checks for the left and right position. Since 6 is higher than 4, then we will insert 6 temporarily onto this part, and we are recursively checks for the node 7, the right property of the node 4. Since the right property has node 7 already placed as the node 7, already occupied by the node 7, then we need to recursively check again, check if 6 is higher than 7 or lower than 7. Since 6 is lower than 7, then we need to place on the left part. Let's say if the node 7 right here is replaced as the node 5. If the node 7 here is 5, let me draw this. If it is 5 other than 7, then we need to insert the 6 onto the right part. We are inserting 6 on the right part. Since it is 7, then we are placing 6 on the left part. So to checking if the parent is higher or not, if the parent is higher than the data itself, then we need to place the data onto the left part. If it is the data is higher than the parent, then we need to place on the right part after the parent node, which is on the right property of the node. So let's implement this. We are using Java 7 as our language. If you want to use something else other than Java 7, then go ahead and encourage you to do so. And for the first check, we need to declare the node. Check if the node itself is already empty recursively. Since we are using the recursion, then we need to check from the back of the code then to the front of the code. The first one, which is checking the edge case, check if everything is already null. If the root is already null, checking if root is already null. We cannot simply use the exclamation mark in front of the root parameter is because we are checking a node. Then we can use the double equal sign, check if it is null, because we are using a class node right here, and we cannot simply declare root as the null in front using the exclamation mark in front of the parameter to check if the root is null or not. Then we can simply declare this explicitly using the double equal sign, unlike other parameter which is integer or string or anything, to check for fallacy values. And we need to declare the new node called the node with the data type of node, just new node, and we need to declare a new constructor of the node new node constructor, which just takes one parameter of the integer data as explained on the linter. Then we can insert the data, pass in the data from the parameter as the first parameter of the node right here. And after we create this as the new node, we don't have to declare this as the left property and right property as the null, but if you want to, then go ahead and we can check for the next one. But before that, we need to assign this as the root part. Root equals to the new node. And for the next one, we need to check using the else if the data is higher than the root itself. This root.data, we are comparing both integers, since data on the root node is in the form of integer, then we need to compare them both from using the parameter right here, second parameter. Check if the data is higher than the root.data, since 4 right here is lower than the 6, then it will check on the right side, recursively checks on the right side or the right property. We can assign the root.right equals, don't worry, I'm using the recursion, using the insert, using another insert inside of the insert function, calling the another insert, passing the parameter, the first one, which is on the insert right here. On the parent insert, we have the root as the data type of node. Then we can pass in the root.right, recursively checks for the right node, and the 6 will be traversed through the 4 and then 7 instead of 2, because 6 is higher than 4. Then it will recursively checks for the 7, check if it's null or not from the if else check right here. And we are passing root.right, and we are passing the data. For the next one, we need to check else if again, check if the data is lower than the root.data. If it is, then we need to insert, you guess it, using the root.left. And we used another recursion approach, using the insert, passing the root.left, and we are passing the data from the parameter on the second parameter, and we are just passing the data, and we are passively drilling on the traversion right here. Check if the data is lower than the root.data. Since 6 is lower than 7, then we need to check using the accessing the root.left equals the insert. Why we are using the root.left and then equals inserting this into the root.left property is because we are returning our new node. We are returning the new node into the left side after recursion check from the if else check right here. Instead of using the new node, this is my mistake, and I'm going to use the root, passing the root itself as the answer. So that is the public static node right here from the parent function of the insert, and it expects a data type of node. Then we are passing the root itself as the returning function. So if we happen to call this on the root.left, since 7 has the root.left of null, then we need to call another insert of the root.left, accessing the root.left, since we are visualizing the root.left already null right here. On the 7 we have the null, which is on the left property of the 7. It's expected to be inserted as node 6. Since root.left is already null and we are accessing the null parameter, and then passing the data, then the insert will be accessed again, and it will check again from the first if check right here, because the first parameter of the root is already equals to null. Then the if check from the first part will catches the null part, and it will be processed as the new node, creating a new node using the data parameter from the pass insert right here, second parameter, and then we are accessing the root from the null into our new node from the constructor right here. Then we are ultimately returning the root as the root.ref right here. And then since root from the parent node is already declared as the 4 to 7, 1 and 3, then we will return in the whole root, the whole head of the root of the head reference, and we are returning as our final answer, and checking if from the 4 right here, checking the since data is higher than the root data, which is root 4, then we'll check if check will catch on the this part. Then we are checking the insert and root, accessing the root dot right, and we're accessing the 7. This is the state that we are in. Then for another check, we are checking this part since data is lower than the root data, which is data 6. Then we are accessing the left part of the node 7. Then node 7 will insert the node 6 because of the if check right here from the final if check, and we can just return the new node, and the else if will not be triggered, and we just return the root as the whole new composition. So let's run the code to see if it works. Let's submit this to see if it really works. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.